All right, so welcome to this week's Unikernel application spotlight. This week is early because I've got stuff going on this weekend, so we're gonna get this one out the door. This week we are looking at Starlark, and so this is it's a language. I'm putting that in quotes. Maybe it's more accurate to call it a DSL. So it's a domain specific language. This came out. So obviously this is under the Facebook Meta.org, but it actually comes out of Google, and it comes from their Bazel/Blaze build tooling ecosystem. If you're familiar with that, and so it's like a cross between the various configuration formats that are available. So you have like your JSONs and your YAMLs and all that sort of stuff, and then an actual language. And so in this case, it's basically like a dialect of Python at the end of the day, and you basically mashing those two together. So why would you want this? Well, in large build environments, which Facebook and Google obviously have some large build environments and build tooling and so forth. You get to the point where like a make file or something else is just not good enough. It's because it's such a large project, and so that's like where this concept of like having a more DSL built for that works. Now, you might be wondering, well, like Ian, hey, like, what the fuck, like, what is a build environment tool gonna do in Nanos? Because Nanos is pretty opinionated, in the sense that it's not really meant for that. So it's when you think about a build environment, you're compiling a bunch of programs, you're probably running a lot of programs. I mean, like right there, you're breaking some cardinal rules of unikernels. So that specific application might not be a fit. However, DSLs like these, where you have like this mishmash of, a language that's tuned for configuration. Let me put it that way. There's a lot of other applications out there, right? So you could think data engineering pipelines. If you've ever done any heavy data engineering work, pipelining is a big concept there. And so there's 1,000 different ways to like send data from one point to another, or mesh it up or transform it en route as you're sending it to another stage of the pipeline. I mean, this would definitely be like one good use case for this sort of stuff. And this, since it's written in Rust, it's going to be a lot faster than the Python implementation. I guess before we go down this route, just to show you, there is a spec for this language, by the way. So there's a whole spec here, which is great because like there's a lot of languages without specs. I mean, hell, Rust didn't even have a spec for years, right? So the fact that they have this is great, and the reason why is because there's multiple implementations of this. So like over on Google, now we're looking at Google. They have one in Go. So we got one in Rust, one in Go. There's one in Python. I think there's one in Java. There might be other variants. Today we're looking at the one in Rust. Doesn't really matter though, because they all conform to the spec. So it's always good to have a spec for your language. Anyways, back to use cases. We mentioned data engineering pipelining. So I think that's like one use case where it would be applicable in a unikernel environment. Supply chain software. So there's a lot of moving parts in supply chain as well. And again, like you have these massive sets of configuration that you have to do. Think like your average form, being shoved into a database, but like on steroids. Just like every toggle you can think of, every field you can think of, just like hundreds or thousands of these things. So that kind of screams configuration, right? Because like, who the hell wants to fill out 100 different, input fields and so forth like that? No, what you have is you have templates where each template will fit a certain order or certain, customer or whatever it is. And so that's where something like this would maybe come into play. Financial modeling. So, if you're in the finance world, maybe you're on the East Coast instead of the West Coast. So that's another place where configuration, like pre-templated configuration or scriptable configuration, that's a huge key here. Scriptable configuration, can be a big deal. So we went over some of the use cases. Let's look at some of the code. So our most basic thing, right, is just this. So we can do. See if I just can scroll up here. Let's just see. Okay, so our most basic hello world here. We're just gonna add these two numbers for high.star. I stole this other example, coins.star, from their example, and so we just got this little hash here, and we're going to print it out by name, and we're going to print it out by value. Instead of doing this, we can just do this -a coins star. The -a basically, first off, it passes that argument into our program. But the other thing is, Ops is smart enough to realize that this is a file and not just an argument, and so it'll go ahead and add it to the to your file system as well. So this is a little bit faster and easier than having to throw this into the config. We can look at the package. I don't think there's anything interesting in the package though. But let's go ahead and take a look at it. Starlark. Yeah, I don't think there's like almost anything in here that's worth looking at. I think I just typoed this. So this is worthless. Somebody should repackage this. Package. Let's see if there's anything in here. Yeah, this is pretty basic. There's nothing special going on in this. It's just a REST package. The entire thing is about 20 megs, so it's pretty lightweight. I mean, it's definitely lightweight than a full-blown Python interpreter. Like, I don't think you can get a Python interpreter for less than 20 megs because you get that package with all the shared library crap in it, right? So, but yeah. So we forgot to mention some of the features on this. We mentioned some of the use cases, but some of the features. One of the things is this concept of deterministic output. So especially like build pipelines, which is where this comes from, you really kind of want the same result every time you run it. You don't want just like random crap mutating in your build pipeline. So that was a key driver for this language. The other thing is that being a build pipeline, they want to take advantage of as many cores and as many threads as possible. And so that's another kind of driving purpose. Some of the stuff that they do to kind of get around this, I think they mention it in here. Mentions it in one of these projects. So like globals in particular get frozen. So none of these Rubies mention it, but so that's one thing is that like in Python and Ruby and other languages like that, it's very easy to mutate globals because there's not a lot of scoping. And so while you can do those in those languages, that's not something that is allowed in Starlark. But that allows Starlark to get a performance boost, and it allows it to get the determinism, and it allows it to do a whole bunch of other interesting stuff that is hard to do in Python. And so that goes back to the question of like, why did you guys invent a new language? Yada yada yada. That's one of the reasons that they throw out. But yeah, this is this is an interesting project. I almost didn't do it simply because I was like, man, this is a build system tool mainly. But after I thought about it for a while, I was like, no, this can definitely be used for like the data engineering pipelines and supply chain and stuff like that. So, anyways, I'm gonna shut the fuck up. And this was your Unikernel application spotlight, starring Starlark. Till next time.